So today we're going to be talking about factorization, right? Yeah, we're going to be talking about factorization. Now, the first question that should come into your mind is that what is this factorization? So let's jump inside and start talking about factorization. Now, before we get there, here is what we're going to be talking about today. So the definition of factorization, the cases where factorization is needed, the factorization by using common factors, grouping, difference of two squares, and a few questions that we can answer so that we make sure that you understand how to factorize. Now, let's jump in, right? Now, what is factorization? Now, factorization basically is just a process where large mathematical expressions are broken down into smaller expressions, right? Yeah, into smaller compounded expressions. Now, what does that mean? It means that if you get a large mathematical expression, to represent it in a more compounded manner, we're just going to factorize it, and it's going to be a small compounded mathematical expression. Right now, for example, here is factorization happening. So our expression over here, we factorized it and we ended up with this value over here. So what does this mean? It means that we have factorized this, and now we have a smaller compounded version of that. Right now, the opposite of this factorization is what we call expanding. So if you wanna multiply everything inside with 2 and it's gonna take you back to our previous expression, that process is known as expanding. But today we're not going to be talking about expanding, we're going to be talking about factorization. Now let's move into the cases of factorization. Right now, cases of factorization. Sometimes you have to factorize by using common factors. Well, most times you have to factorize by using common factors. Now, inside an expression, you look for the highest common factor of each expression and then factor it out and become left with a smaller compounded version of the expression. Now, there's grouping. Sometimes before you can factor them, you have to group those who have highest common factors. Then from there you can be able to factorize. Right, then there's the difference of two squares. Difference of two squares, it's when we are subtracting one square from another, then we can still factorize that and end up with a more compounded version of it. Right, yeah, let's move. So common factors, taking out a common factor. So this one is simple and straightforward. So you get an expression like this and you look for its highest common factor, and then from there you take it out, and then you leave the rest in the brackets. Now, as you can see, this expression over here is the same as this expression over here, just that this one is factorized and this one is not. Right, it's as simple as that. So you look for the highest common factor, factor it out, and then you are left with the brackets like this. Right, yeah, now this is factoring out by using the common factors. Right, yes. Now let's go to the next one, grouping. Now grouping, we're still gonna factor out the common factors, but in this case we have to group together terms of the expression that have the most common factors and factorize them. So we're gonna look for the ones that they have the most common factors and then take out and then from there group them together. After grouping them together, then we can take out what is common in them. We can take out their highest common factor. Right, now in this case, as you can see, here's our big expression over here. What did we do? We grouped together bx and 7x. Here they are next to one another, and you group together 14y and 2by, and you group them next to one another. Here they are. Then from there we factored out what's common in between them. Now, as you can see, this one, the highest common factor is x, and even from this one, the highest common factor is 2 y, right? Then we started factoring them out. Then after doing that, we found out that they both have something in common. They both have 7 plus b, 7 plus b. Then we factored the 7 plus b out, and then we are left with this last expression over here. So this expression over here is the same as this expression that we started with over there, right? So this is grouping. We group together those who have the highest common factor, and then from there we factor out. We factor out we factorize them, and then follow our process, right? Yes, then next is the difference of two squares. Now the difference of two squares, it's quite different from the others, but then it also follows the same principle of factorizing, right? Now this expression and this expression, it's one and the same thing. Now you may be asking yourself a question, how do I do that? Now as you can see, both these values are perfect squares. Both these values are perfect square. Now if they are perfect squares, then it means it's the difference of two squares. Since there's a minus in between them, it's the difference of two squares. Now whenever you get difference of two squares, this one is quite easier, because what you do, you just find the square root of the first value and the square root of the next value, then just write them here. Write them in the brackets, both of them. Write them in the brackets, both of them. Now in the first bracket you put a minus, in the second bracket you put a plus, right? But then you don't have to put them in that way. I can still put a plus here and a minus here, right? Yeah, but then just make sure that you do that. You find the square root of the first one, and then you find the square root of the next one. Then from there you are done, right? Yeah. Now since we learned how to factorize, since we learned everything, let's jump in and do some questions together, and from there we can be able to say yes, we understand, right? Yeah. Now let's jump into this one. Okay guys, now let's start working with the first one, this one. Let's look for a way on how to solve this one, right? Yes, on how to factorize this one for that matter. So let's jump over to my other screen so that I can actually show you how to solve it, right? Right, there is it. I rewrote it over here so that you can be able to see it properly, right? Now we have negative 2ab squared minus 4a squared b, right? Now first of all, you have to find out what is the highest common factor. Now in this case, our highest common factor is negative 2ab, because we know we have negative 2ab in both our expressions, right? Yes. And then if we factorized a negative 2ab, what are we left here? ab squared. What are we left here? We are left with b, because a is going to take out a, and then b, since it's b squared, 1b is going to go out and 1 is going to remain, and 2 is going to take out 2, right? 2 is going to take out 2, right? And then we come to here and factor out here. What are we going to be left with inside? We're going to be left with a positive 2a, because the b is going to take out the b, and then the a is going to take out 1a, and then the 2, we're going to have the 2 is going to take the other 2, and then we're going to be left with 2. Then there you are, and then this one is factorized. So your answer is negative 2a b open bracket b plus 2a. Now I believe you got that one correct. I believe you got that one correct, and if you didn't get it, I'm sorry, you can try again. You can try again and do it by yourself, and then come back and let's do the other ones. So let's go to the next one. I hope this one you're gonna get it correct. Now let's talk about the next one, right? Yes, so this one, we have this expression over here. We have this expression over here. So we wanna factorize it. So what do we do, right? Yes, now let's go over to our second screen and start working on it. What do? We look for our highest common factor. Now, what is our highest common factor? In this case, as you can see, is 18b squared, right? It's 18b squared. Now, since our highest common factor is out, so we have to write what we are left inside the brackets. Now, over here, we have to divide this one by this one. What do we get? Then we're going to be left with 4 we're going to be left with b, 4, just 4, because the b squared and the b squared will cancel out. Then we're going to be left with 72 divided by 18, which is 4, right? Yes, minus 18 divided by 18, that's 1, so we don't have to write it. And then here it's b cubed and b squared. What are we left with? We're just left with b, because the two of the b's there are going to be taken out, right? And then here, what are we left with? We are left with cube, because this one, there's nothing to factorize, there's nothing to take it out over here, so we're going to be left with it as is. And then that's our answer, right? Yes. Now let's go over to our the next one. Now the next one is quite different, because it's another scenario that you're gonna come across. So we have our expression over here. There we have our expression is 16k squared minus 4. Now, as you can see, this is a difference of two squares. Why? It's because both of them, they are perfect squares, right? Then it means that this is the difference of two squares. Now remember, when finding the difference of two squares, this is way more simpler. You just find the square root of each and every one of them, right? After you find the square root of each and every one of them, and then we know the square root of this one is 4k, and the square root of this one is 2, right? Yeah, and then you just put 2 brackets over here, 2 brackets over here, then 4k, and then put 2 here, put 2 here. One of them you put plus, one of them you put minus, then you're factorized. Let's go to the next one and solve it. So our next one is this one. So let's now solve this one. I hope you tried it, but let's go ahead and try it out and try solving it. As you can see, this is the same as the previous one. It's still the difference of two squares. So as simple as it, you just find the square roots of both of them, square root of both of them. Since both of them are perfect squares, then it means we are working with the difference of two squares. Yes, you find the square root of both of them. Now you know the square root of this one is a b c, right? And the square root of this one is 1, right? Yeah, then you just put the brackets there, then first start with a b c, then a b c, then 1 1. Here you put plus, here you put minus, then there you are, you're factorized. Now let's go ahead and solve the next one. So here we have our expression over here. It's quite a big expression, but then let's jump over and factorize it, right? Yes. Now, as you can see, we have 5x plus 10y minus a x minus 2ay, right? Yes. Now, as you can look at them, they are all they both have common factors between them, so we don't have to reshuffle them and put them in another manner. So what we can do, we can factor out in this one and this one, we have highest common factor in each and every one of them. So let's try factorizing them and finding the common factors. So here, if we factorize this one over here, then we're gonna have we're gonna take out 5 because it's the highest common value, and then it's gonna be, what are we gonna be left with on our first place? We're gonna be left with x plus 2y, right? Minus, we factorize this one also. What are we gonna take out? We're gonna take out a. We're gonna take out a. What are we going to be left with? We're going to be left with x minus 2y, right? As you can see, both of them have the same brackets, so we can still factorize them. We take out the brackets, which is x plus 2y. No, this is supposed to be plus. right? X plus 2y, and then what are we left with? We're left with 5 minus a, right? You're left with 5 minus a. Then there you are. We are done. So there is your factorized value.